We've got our subroutine in place. It's taking care of the scaling. We're passing a value into it, it's doing its scaling, and then we're bringing that value back out of it. Okay, let's put our other two rooms back into the program and see if the program will work properly if we use the same subroutine to scale each independent temperature sensor. Okay, so we want to recreate this block of logic 2 more times. Righto, grab a move. This time move temp2 to temp storage. Jump to subroutine 1. Move the result from scaled storage to scaled temp 2. And with a less than compare, bring on heat 2 if scaled temp 2 goes below 20 degrees. And one more time, move temp 3 to the same temp storage spot. Jump to subroutine 1 so it can scale the value for us, and then move that value that has been scaled from scaled storage to scaled temp 3. Then bring on heat 3 if scaled temp 3 goes below 20. Okay, that was much easier than having to write out the details in the scale with parameters function over and over, wasn't it? But will it work? Let's find out. The moment of truth, right? Jump into the sim. Okay, first temperature sensor, temp 1. It brings heat 1 on and off independently. Beautiful. Temp 2. It brings on heat 2 independently. And temp 3 brings on heat 3 independently. Beautiful. Works like a charm. Now, if you thought that each input sending its value to the same address here might cause some conflicts in the program, let's investigate to see why it doesn't. Okay, so jump out of the sim. Let's break the program down into scan cycle type segments. I know how much you love talking about scan cycles. Okay, these are our inputs, right? When the PLC scans the inputs, it checks to see if there is a signal here. If there is, it puts a 1 at this address. And in the case of these analog inputs, it checks to see what voltage is coming in and then converts that through the use of binary code to a number between 0 and 4095. Okay. Each one has a different number because I've moved the sliders into different positions, right? In the real world, this represents different temperatures in each room. Okay, so the PLC has scanned the inputs. Done. Then it comes time to execute the ladder logic. We start here, obviously. It is a 1, true. So this is true. Write a 1 to this address. Easy, you've done that before. Next rung. Move this number from here to temp storage. Don't worry about down here, any of this. We haven't got there yet, so it's not important yet. Okay, next rung, jump to subroutine 1. Okay, so let's jump there. This number from temp storage that lies within this range is converted to the equivalent number within this range and put in scaled storage. If there was more rungs in here, we would continue on. As there isn't though, the subroutine has now been executed and we go back to where we left off. In the main routine, we move what just got put into scaled storage into scaled temp 1. We don't move what's in scaled storage to scaled temp 2 yet because we're not there yet. We're still here at this point in the program. So what we just moved into scale temp 1 stays in scale temp 1. This rung is executed next, and we know how that works. Easy. Next, we move the value from temp 2 to temp storage. Now, that does not mean we go back up here and rescan this block of code. We've already done this. So this value at scale temp 1 is set. It will not be conflicted by the logic here because it's already happened. Right. So then we jump into subroutine 1 again. The new value at temp storage is rescaled and put into scaled storage as a new value. Then back in the main routine, that new value in scaled storage is then moved to scaled temp 2. Not affecting anything that has happened up here. Scaled temp 1 is still scaled temp 1. The only thing that's been changing is the scaled storage and the temp storage values. Okay. This rung here, the compare function will compare the scaled temp 2 value with this value and put a 1 at this address if these conditions are met. Then the last blocks of logic here are executed, which work the same way. The scaled temp 3 is set. If these conditions are met, the PLC will write a 1 in this output. The ladder execution is now finished. The PLC will then update the outputs. So whatever happened at these addresses during the scan, whether they got a 1 put in them or a 0 put in them, will either turn on the outputs or turn off the outputs. You know how that works. Easy. Then some housekeeping, and then drop the mic. Only joking. But seriously, you can see how useful subroutines are if you want to execute the same logic over and over. You can just write it once, put it in a subroutine, and just call it or jump to it whenever you need it as many times as you like. Well done, guys. Save your work. Cheers.